Okay, welcome to this demonstration on robot navigation. This is for a hardware controller class at UCSD Extension. The robot is a Parallax robot that can be purchased at SparkFun. So what you're going to see here is a quick demonstration of the actual product. It's again the Parallax robot with infrared receivers, and I've put a program on it that will simply sort of walk around the house a little bit, and it'll adjust to the walls. So you'll see the little LED lights flashing on it temporarily. So what I'm doing here is shutting a door, and so we're going to have the robot approach the door and wait until the door opens before he proceeds. So what you'll see is him, the IR sensors lighting up the LEDs until he sees the doors close, and then when we open the door and he gets a straight signal, he'll go through it and turn around and again wait until the door opens. Now this part is a little bit odd because it is tricky to get the robot to square up to the door. So what we're doing here is I'm using some junk mail to actually get the robot to square up to the door before we open it and let him proceed. And again, so part of the program function is the robot will adjust to any objects in its way, so we can sort of manipulate it by putting a little piece of paper in front of the robot, and he'll adjust slightly to that obstacle and keep going. And yeah, so at the end here, we're just going to do a little James Brown to finish up the demonstration. So just to go over some of the code here real quick. Again, I'm going to post all this on the internet so anybody can get after it who wants it. But really what we're doing here is trying to gather all the variables associated with this small application, and we're just putting them here at the top of the script. And these are the things that you're going to, if you use the code, you're going to want to adjust for your own course, if you will. And you know, again, in it, your servos and your infrared sensors to get the to start working. And then we have a section of wheel movements. It's pretty straightforward. We're basically telling the robot what to do at certain times with the case statements and enums, and it'll basically say, you know, go forward full speed or turn left or turn right, depending on the condition. And again, I mentioned some enums. So this is the move sequence. We're going to go forward. We're going to do a quarter turn. We're going to walk towards the door. We're going to go through the door. And once we get through the door, we do a half turn. Blah, 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 blah. Oh, we're also keeping, I don't know if you saw, I moved really fast there, but we're also keeping track of what move we did, what was our last move, and what move we want to do. This section here is on the IRs. They are fairly inexpensive, but quite effective. So with them, we're using them to sort of adjust the robot again to obstacles. And the need to do that is because this robot has a tendency to drift off course, or you know, the variables with the turning, quarter turn, half turn, you know, may leave the robot facing a direction that's not desirable. So I had to add some functions in to adjust its direction depending on which IR receiver was receiving a hit. And you'll see the last section of the statements blank, and you know, depending on your, you know, what you want to get out of the robot, you can go ahead and fill that in and make it work for your own condition. And again, the last thing here is this is the main loop of the program, and this is basically where he walks through the moves that we set up in that enum and executes the appropriate wheel turns, whether it's a left turn or forward full speed. And in between, we're running this adjust direction function. So every few seconds here after the move, we're going to test to see if there's an obstacle in our way. It's probably not the best way to get this to work. I think if you're a larger organization, you may paint white lines on the ground and have the robot follow something very specific rather than having this need to do wall detection. But can be quite handy and provide a foundation for any type of robotic application, even similar to what the iRobot application does, where it sort of vacuums your house. And again, here's a link. So thank you very much for watching.